welcome back to science class. Today we're going to talk about ice, lots of ice, and we're also going to talk about feedback loops. Now when we talk about ice, we have two main categories for ice. We have glaciers and we have sea ice or ice floes. Now glaciers are made of snow that is piled up and piled up and piled up in layers and has been kind of compressed and cooled and frozen into ice. They are massive and thick and intricate, and they are found on land. We can actually think of glaciers as frozen rivers because they actually move, albeit they move very slowly, but they do move. Glaciers cover about 10% of the Earth's surface, most of them being in Antarctica and on Greenland. We can find glaciers in the north and the south near the poles, but we can also find them in pretty tall mountains, so like the Himalayas or the Alps or the Andes or the Rockies. Now, an ice floe is a sheet of ice that floats on the surface of the ocean. We also call them ice sheets. These ice sheets or ice floes form during the cold winter months, and they grow and cover the ocean. And they're often covered in snow. So they're pretty thick, you can walk on them, and in fact lots of animals use them to hunt and stuff, like polar bears. Polar bears will use them to hunt for seals because they know that the seals live underneath the ice and that they also have to come up for air every now and then. Not only do polar bears use the ice for hunting, but also people like the Inuit. Now, ice floes are actually really important in helping regulate the Earth's climate. You see, these ice floes are white. White is a reflective surface. This means that whenever there is sunlight that comes in, that sunlight and that heat, a lot of it will get reflected up back into the atmosphere. It won't be absorbed by the dark water underneath. So it actually helps to keep the climate cool. The problem is that we are seeing less and less sea ice form every year. So let's ponder the question, what would happen if all of the ice in the world melted? Well, let's talk about sea ice. What happens if all the sea ice melts? If all the sea ice melts, then we don't have that reflective surface bouncing off the light and the heat anymore. So that means that the oceans are going to absorb more heat. And we know that if the oceans become too warm, that disrupts a whole bunch of things. Melting sea ice is one thing, and it's problematic in itself. But if we talk about glaciers, like I said, glaciers cover 10% of the Earth's land area. 10% is a large number, especially when we're not just talking about area, but there's also volume. There is a lot of ice on Earth. There are lots of glaciers on Earth. And if all of the ice in those glaciers melted, the sea levels would actually rise 70 meters. Think about that. 70 meters. This school that I'm in right now would be underwater. Now, of course, this won't happen overnight. This is going to happen over a period of time. And normally, this would be a natural thing, if it took thousands of years for it to do this. Right now, we're seeing glaciers melting at an incredibly fast rate, much faster than what is normal. So if we consider that most of civilization is built along the coasts and along rivers, and those coasts and rivers are going to disappear, then we suddenly have a lot of climate refugees. These refugees have to go somewhere, and so they're going to be forced to travel inland. This can cause a lot of problems. This can cause conflict, this can cause famine and food shortages, and it also disrupts a bunch of people's daily lives. Diseases can start to grow more and spread faster because they're going to be refugee camps that don't have a lot of access to sanitation products or healthcare or anything like that. This is going to be a major problem in the future. Not only will there be lots of refugees and the sea levels rise, but like I said, if the oceans become too warm, then the thermohaline circulation stops. But that's not the only thing. When you melt all of the glaciers, that water is fresh water. And when you pour that into the Arctic and Southern oceans, which, let's be honest, most of the glaciers go towards those oceans, you suddenly are diluting the water. So not only is the water warmer, but it's also less salty. Warm, salty water is not going to want to sink. So that is going to disrupt the thermohaline circulation even more. In fact, it might even stop it completely. We don't know. We know that melting ice is pretty bad because we're going to have to face a lot of problems. Right now, I want to focus on the climate change problem. So we're going to focus on the sea ice just for a moment here. Now, when sea ice starts to melt, it reveals some of the dark water that's underneath. This dark water is absorbing the heat from the sun. So when it absorbs the heat from the sun, this water becomes warmer. And guess what the ice is floating on? It's floating on the warm water. So when the water gets warmer, more ice melts. The more ice melts, the warmer the water gets. You see the pattern here? This is called a positive feedback loop. And it's not positive in that, oh, this is a good thing. It's positive because it's amplifying the effect that we're seeing. The effect being the loss of sea ice. So to give you some background information about feedback loops, there are two kinds. There are negative and positive feedback loops. Feedback loops actually can amplify or mitigate, reduce. So in this case, the melting of the sea ice, revealing more water, warming the ocean, melting more sea ice, this is a positive feedback loop that amplifies the effects of climate change. Now, you can have a negative feedback loop as well. A negative feedback loop kind of tries to bring everything back to balance. Think of it this way. Positive feedback loop means that your seesaw, your balance, is completely out of whack. And when you put on a negative feedback loop, it tries to balance it out. So that's how you can think of positive and negative feedback loops. As we know, climate change is very problematic, and we humans are actually speeding it up. We are speeding it up by burning all kinds of fossil fuels that cause a lot of carbon dioxide to be emitted to the atmosphere. This carbon dioxide traps the heat that comes in from the sun, and it doesn't let it escape as usual. So it's warming up the air around the Earth. Not only is it warming up the air, but it is also causing things like the melting of the Arctic. We know that the melting of the Arctic is problematic because the sea ice helps to keep the Earth cool by reflecting a lot of the heat back into space. If we no longer have that ice, that heat gets absorbed even more, causing even more warming of the Earth. This can lead to further problems down the road, such as rising sea levels, causing a lot of people having to leave their homes to become climate refugees, causing famines and droughts and food shortages and war. These are problems that we are going to be facing in the future if we don't change something. Thank you all for watching, and I will see you all next time. Bye!